Welcome to Unit 2. Unit 2 is all about absolute value equations and inequalities. Today we're going to look at how to solve absolute value equations. So by the end of this video, you should be able to solve absolute value equations both algebraically and graphically. So let's start with something that you should already know. In the last unit, we talked a lot about how to graph different functions, including the absolute value function. So let's start by graphing y equals the absolute value of x minus 2 minus 2. This would mean that h is 2 and k is negative 2. So we're going to start our graph at the point 2, negative 2. And a is 1. So our graph is not stretched or flipped. The question is, what are the zeros, solutions, roots, or x-intercepts? Those four words all mean the same thing. So if you look at this graph, you can see that the x-intercepts are at the point 0, 0 and the point 4, 0. Or that the solution set to this equation are 0 and 4. Let's take a look at another example. This next equation is y equals negative 3, absolute value of x plus 2 plus 4. So that means h is negative 2 and k is 4. And then a is negative 3. So that means that the graph is going to be flipped upside down and stretched. Now looking at this graph, it's a little tougher to see where the zeros, solutions, roots, or x-intercepts are from the graph because they are not integers, they're decimals. So sometimes graphing is not the best way to find the solutions or the x-intercepts. Sometimes it's better to do the algebra. So for right now, I'm just going to write that these are decimals. So let's take a look at a better method for solving absolute value equations other than just graphing. So there are 4 steps for solving absolute value equations. The first step is to isolate the absolute value. That means that the equation should be absolute value of something equals everything else. There should be nothing on the side with the absolute value except what is inside the absolute value. The second step is to split the equation into 2 separate problems. And I'll show you how to do that in a minute. The third step is to solve both equations. Which is just regular algebra. And then the fourth step is to check your answers. Checking your answers is extremely important when it comes to absolute value equations because sometimes you can end up with these things called extraneous solutions. That means that you do all of your math correctly, but when you check your work, one or both of the answers might not work. They might not make the original equation true. And I'll explain more about that when we look at a couple of examples. So you have to check for extraneous solutions. And you do need to remember that word extraneous. So let's take a look at a few examples. The first problem is absolute value of 2x minus 5 equals 9. So step 1 was to isolate the absolute value. So on the left side of the equation, the only thing that we have is the absolute value bars and everything that's inside of it. So that is already by itself because there's nothing else on the left side of the equation. Step number 2 is to split the equation into two separate equations. Now, hopefully you remember from our discussion of absolute value functions earlier this year that if you take the absolute value of 2, you're asking how far from 0 is 2? The answer is 2. But the absolute value of negative 2 is also 2 because negative 2 is also 2 units away from 0. So because both negative numbers and positive numbers can have the same absolute value, you need to split the problem into two separate equations. That way you can solve for both cases. So the first equation is always just the original. The second equation, you need to change the sign of everything in the absolute value bar. Because as I just said, here the absolute value of 9 is 9. The absolute value of negative 9 is also 9. So I need to check and see what happens when the stuff inside the absolute value bars are positive and when they're negative. So step 3 is just to solve these equations. So just like Algebra 1 when you solved linear equations, on this first equation you would add 5 to both sides and then divide by 2. On the second equation you would subtract 5 from both sides and then divide by negative 2. So my two answers are x equals 7 and x equals negative 2. Now we need to check our solutions. So you can do this by plugging 7 in for x in the original function. Always plug your answers into the original function. Or you could use the calculator. So let me show you how to check your answers on the calculator. You find the absolute value bars by clicking Math, going over to Num, and then the first choice, ABS, stands for absolute value. And you can see when you click on it that it brings up absolute value bars. Okay. Now, the best way to check your solution is to use the store button. So I'm going to say step 7, store that for x, and then hit enter. Then the calculator is going to plug 7 in wherever I type x. Then if I type the equation, math, num, abs, 2x minus 5, I get 9, which is what I wanted. Now I'll check the other solution. So if I say negative 2, store for x, and then you can either type the equation in again, or you can scroll up to the equation, hit enter, and then enter again. And it tells you that the answer is 9, which means both of these check. So those are both our solutions. Then it says to graph these on a number line. So I need to make sure that my number line includes all the way from negative 2 to 7. And then when I plot my points on the number line, I just put a dot at 7 and a dot at negative 2. Let's try the next example. Remember that the first step is to isolate the absolute value. that means I need this section of the equation to be the only thing on that side of the equation. So if this was the equation 3x plus 4 equals 0 and I wanted to solve for x, I would start by subtracting 4 from both sides and then dividing by -3. Then I can split my equation into two equations. The first equation is always the original equation without the absolute value bars. The second equation, remember that you change the sign of everything inside the absolute value bars. And then you solve. So for the first equation, I'm going to subtract 2 from both sides. And you can use your calculator to help you with the fractions, or you can subtract the fractions. So subtracting 2 from 4/3 would be subtracting 6/3. So the answer is -2/3. On the other equation, we would add 2 first. So that's adding 6/3, give us 10/3, and then divide by -1. Then again, we need to check our answers. I'll use the store button to say -2/3, store for x, and then type in the original equation. Always type the original equation. And then since here we're at the end of the absolute value bars, you need to hit the right arrow so that you can continue typing +4. That gives us 0, so that works. And then let's check -10/3. Great, so both of those answers work. Then we need to graph our answers on a number line. So the fractions might trip you up, but if you look at the calculator, you can see that -2/3 is equal to -0.67, and that -10/3 is equal to -3.3. So we know that our graph needs to include at least the numbers -3.3 and -0.67. So I'm going to start my number line at -4. So -2/3 is about here, and -10/3 is about here. Oops, over a little bit more. Okay. Now if you flip your paper over, we're going to look at 2 more examples. Same directions, we want to solve and graph our solutions on the number line. So for the first example, let's think about absolute values for a second. If you take the absolute value of 4, what do you get? 4. If you take the absolute value of -4, what do you get? 4. Is there any way you can take the absolute value of something and get a negative answer? No. If you're not convinced of this, think about the graph of an absolute value function. The graph, okay, the range is 0 to infinity. The graph never reaches -4. So these should be the easiest problems you see on any kind of absolute value quiz or test. If you have first isolated the absolute value, and you have that an absolute value equals a negative number, the answer is no solution. Because there's no way you can get an absolute value to equal a negative number. If you follow the steps and do all the work and go back and check your answers, you will find out that neither answer works. So you can do all that extra work, or you can just know that absolute value can never equal a negative number. So since there's no solution, there's nothing for us to graph on the number line. Let's move on to the last example. So step number 1 is to isolate the absolute value. The absolute value is the only thing on that left side of the equation, so step 1 is done. Step 2 is to split the equation into 2. So we have x minus 3 equals 3x minus 5, and negative x plus 3, because remember you have to change the sign of everything inside the absolute value, equals 3x minus 5. Then we need to solve those equations. So if you move all the x's to one side of the equation and all the numbers to the other, if you subtract x from both sides, you get 2x, and then if you add 5 to both sides, you get 2, and then divide both sides by 2, you get x equals 1. For the other equation, if you add x to both sides, you get 4x. If you add 5 to both sides, you get 8. Then you divide by 4, and then you get x equals 2. So let's check our answers. So these are a little bit trickier to check our answers because we have x's on both sides of the equal sign. But we'll start by storing 1 for x. Then we can type x minus 3, and that gives us 2. So if I type in the other side of the equal sign, it should also give us 2. So if I type 3x minus 5, that gives me negative 2. So that means that 1 is an extraneous solution. Let's check 2. If I store 2 for x, then I type in absolute value of x minus 3, I get 1. And then if I type in the other side of the equal sign, 3x minus 5, I also get 1. So 2 works. In this case, you need to clearly mark which solution works and which one is extraneous. So when we go to graph this on a number line, say 0, 1, 2, 3, 4, we do not graph 1 on this number line because that is not an actual solution, but 2 is, so that should be the only point on our number line.